Do I need to bring it up or?
No, I should be able to tell
Okay,
you.
perfect.
So it's from section 5.5,
Yes.
and it is x, and in parentheses 4x plus 5 to the 8th power dx. Yes.
Good. So I'm assuming this is a definite integral, indefinite integral,
Correct.
and we're asked to find basically the most general antiderivative. Perfect. Okay. I'm having difficulties with this. If this were any other, like I don't know, first power, second power, at the most, I would have distributed and I would have been done by now. But this is power 8, so I really want to denote by anything you want other than x, 4x plus 5. And then du equals 4 dx. Because when I differentiate this function, I only get 4, but this is not the derivative of u. This is du, which is f prime times dx. Do I have the 4 outside? No, but that's never an issue. Put a 4 and 1/4 inside, outside, and you're done with that. So now let's see how we change this integral. There is a 1/4 outside. 4 times dx. This piece and this piece will form du. This piece is u to the 8th. But I have an x in here. I cannot copy x. This integral doesn't have x anymore. It's done. But how do I determine this x? Right here. I will solve for x, subtracting 5 and dividing by 4. So from here, x equals u minus 5 over 4. This will replace x. So this is u minus 5 over 4. And you can say, how come that this is, why is this easier than that? Oh, much easier. First of all, I will take 1 over 4 outside, and I have 1 over 16. And then in u minus 5, I will distribute u to the 8th, and I will distribute u to the 8th. So the integral from u to the 9th minus 5 u to the 8th. And this is so much easier than this. No questions, no comparison. So 1 over 16, u to the 9th. I have to increase the power by 1 and divide by the same number. Minus 5, I have to increase the power by 1 and divide by the same number. And then plus a constant c. Inside or outside, it doesn't matter. If I distribute this, it will still be a constant. It's not important. So, not to confuse you, let me put it inside, because I took the 16 and you'll see what happens. Let me put it inside so I can explain further. It doesn't make any difference, but this is what I just did. Oops, that's not a good one. Okay. So, of course, now I will distribute 1 over 16 to this, so I get 1 over 60 u to the 10th. I distribute here, and what do I get when I multiply? I have 16 times 8, 128 with 5, so negative 5 over 128 u to the 8th. And then I multiply, and I get c over 16. But this will be replaced by a generic c. It doesn't matter. It's still a constant. So then, say it again.
Is the u to the 8th supposed to be u to the 9th over 9?
Oh, yes, I did say to add, and I did not. Yes, thank you very much. Thank you.
Yeah, no problem. Sorry, I didn't know.
No. No, you didn't do anything. So I did something. So my apologies, 16 times 9, of course. I said that, and I didn't write it. So it's 144. Thank you very much. Thank you. My apologies. And So then the final simplified form, I have to replace u by this, because the integral is in, or the function is in terms of x. I have to present the answer in terms of x. So we have 4x plus 5 raised to the 10th minus 5 over 144, 4x plus 5 to the 9th. And I'm checking everything. So this was 9, so it's 10, and this was 8, so it's 9. Yes, correct. Sorry about that. And then plus a constant c. And you can always go back and check. Thank you, Brian. I appreciate it.
Yeah, no problem. Thank you very much.
Thank you. Is this okay, Sean?
Yes, it is.
Every step?
Yes.
Perfect.
And then I have one other question.
Yes, please.
It's also from 5.4.
Very good.
About the definite integral. And we have a lower limit of 0 and an upper of 9. And this is x divided by the square root of 4 plus 5x. I'm sorry, it was 4 plus 5x.
Sorry about that. I'll erase it.
Yep. Well, with no 4x. Yeah.
Very good. So the same idea, I really want to get rid of that 4 plus 5x under the square root. And I'm thinking of I'm thinking of looking at two different options. One option to be u equals 4 plus 5x. And I want to analyze with you this second option. I don't know if it works or not. Let's say y equals the square root of 4 plus 5x. We'll see in a moment if that is a better idea or not. So leave this alone for now. And here I have du equals 5 dx, because when I differentiate this I get 5, but I have the differential, so I have to multiply by dx. So I don't have a 5 in there, no problem. 5 is easy to make up. And now 5 dx is du. The denominator is the square root of u. But again, I have a problem here with this x. But it's really not a problem because I can solve for x in terms of u. So from here, I subtract 4 and I divide by 5. So x equals u minus 4 divided by 5. So the whole integral becomes 1/5. Do not copy the limits of integration, because these limits correspond to x. The limits here will correspond to u, so we're not ready yet. So 5 dx is du. The numerator is u minus 4 over 5. And the denominator is the square root of u. So u minus 4 over 5, the square root of u. Now we are ready for the limits of integration. When x is 0, u is 4. When x is 9, 45 plus 4, 49. Again, like before, this looks so similar to the previous one. We have 1 over 25. And I'll separate into two pieces. U over the square root of u. U over the square root of u is u to 1/2, 1 to minus 1/2. So this will be u to 1/2. And then 4 over the square root of u will be 4 times u to negative 1/2. So then from 4 to 49 in parentheses, and then du. U over this is this, u to 1/2 minus 4 u to negative 1/2. So like before, we have 1 over 25, u to 1/2 plus 1, which is u to 3/2 over that number, minus 4, u to negative 1/2 plus 1, which is 1/2, over the same number, but this time this is a definite integral, so it's from 4 to 49. Before I plug in those numbers, I would like to clean it up a little bit. So I have 1 over 25 outside. I flip and I get 2/3, and this is u to 3/2, but u to 3/2 is the same with u the square root of u. Oops, I didn't mean that. So u the square root of u. I flip and I get minus 8, and this is the square root of u from 4 to 49. I plug in 49. 2/3 times 49, but times 7, minus 8 times 7. Careful now, minus, when I plug in 4, 2 over 3 times 4 times 2. Let me write it as 4 times 2. Minus minus, I'll have plus 8 times the square root of 4, which is 2. Again, very long calculations. Every time we have those square roots, we get long calculations. Okay, so 1 over 25. 14 times 49. And I get 686 divided by 3. Minus 56. And then here I have 4 times 4, right? So 16 divided by 3 and plus 16. So 686 minus 16, and if I divide this by 3, can I get something? No, of course not. So 670 divided by 3. $670 divided by 3, and negative 56 plus 16 is negative 40. Please make sure my calculations are okay. And now I have 1 over 25, the least common denominator is 3. Oops. And I have 670 minus 120. And this is 550. 1 over 25 times 550 over 3. Is it? Yes, 550. If I simplify by 5, I get 110. So 110, and I can simplify by 5 again, okay, in a moment. So 5 times 3. So by 5 again, and I get 22. So the answer is 22 divided by 3. Wow, a lot of work on this problem. I still would like, if you don't mind, I'd like to see what we get if we use this notation, this substitution. But let me, before we do that, let me see if you have any questions on what we just looked at. It was long. Do I know for sure that this is correct? No, I could have made an error in the arithmetic of all this anywhere. So I'm just hoping that you kept up with my numbers. So that was again 49 times 14.
I put it into WebAssign and it worked out.
Oh, okay, then that's fine. Thank you so much. Good. Thank you for saving me from going through that excruciating checking. But I still would like to see if this takes us on a shorter path. Okay, so I'm just going to start from scratch. There is no room there, so So we have the integral from 0 to 9 from x dx over the square root of 4 plus 5x. If I say y is the square root, let's see if that makes any difference. dy equals 1 over 2 the square root of 4 plus 5x times the inner function, which is 5, prime, which is 5, times dx. Ah, potentially quite nice. Okay, so I don't have 5/2. Who cares? I can make up a 5/2 multiplying by 5/2 and multiplying by 2/5, and this is 1. Simplify, simplify, that's 1. But now, yeah, I still have to make up this x. So I have to square both sides, and I get y squared equals 4 plus 5x, and then x will be y squared minus 5 over 4. Okay, let's see. I have 2/5 inside, outside. The integral from, again, the 5, the dx, and 2 and this, they're all du. And x is y squared minus 5 over 4. Yes. Although initially it looked more complicated, it's not. So when I plug in 0, careful, do not copy the limits of integration. So when I plug in 0 for x, when I plug in 0 for x, I get the square root of 4, which is 2. When I plug in 9, 45 plus 4 is 45 plus 4 is 49. The square root of 49 is 7. Quite nice. So 2/5 multiplied by 1/4. The integral from 2 to 7 from y squared minus 5 dy. Much nicer. I'll simplify by 2, and I get 1 over 10. And this is y cubed over 3 and minus 5y. I have to increase the power and divide by the same number. And this is negative 5y prime is negative 5 from 2 to 7. Okay. I better get the same answer. It has to be. So I have 7 to the third power. 40, so 7 to the third, I get 3, yes, 343 over 3 minus 35. Careful now, minus 8/3, but plus 10. Much easier calculations. Okay, let's see. 1 over 10. 343 minus 8 is 335. Keep my numbers correct, please. Minus 25. 1 over 10, the least common denominator is 3, and this gets a 3. 335 minus 75. Okay. So 30 and what is this? 0, and I have a 6 and I have a 2. And oops, what was the answer? 22 divided by 3. I messed up something. And what did I mess up? The answer has to be the same. 1 over 2, the square root, 5 dx, 5 over 2, 2 over 5, yes. Squared, y squared, I'm sorry. It's y squared minus 4 over 5, sorry. Y squared minus 4 over 5. Sorry. Okay, so this is 5. So I can simplify. Simplify, and I have 2 over 25. Sorry. So 2 over 25. This is still okay. This is not okay. Okay, 3/3. This is 275, and a 2 over 25 in front, and this is just 3. Let's see what we get. And how much is 275 divided by 25? And that's 11. And we do get a 22 over 3. I have to erase that because I can't write over it. It's still wet. And yes, we have to get the same answer. I rushed and I shouldn't have.